Welcome to The Explainer. Ever wondered what actually happens when a piece of malicious software gets discovered? Well, today we're pulling back the curtain and stepping into the world of digital forensics. We're going to follow the digital detectives who take this stuff apart, piece by piece, to figure out how to stop it.
So, what's the big secret hiding inside some random malicious file? Let's find out. We are going to trace the exact journey a cybersecurity analyst takes to crack the case, revealing what makes this malware tick, and more importantly, how to defuse it.
You know, every investigation like this starts with a single suspicious file. It's a complete unknown. Is it harmless, or is it a digital time bomb just waiting to go off and cause some serious damage? That's what the analyst has to figure out, and fast.
And look, the mission here isn't just to slap a label on it. It's way deeper than that. The goal is to figure out its entire purpose. What was it designed to do? Who might it be targeting? And, of course, the most critical part, what's the kill switch? How do we stop it?
Okay, so before you even think about double-clicking that file, the first and most critical step is to set up a safe environment. You can't analyze a threat like this on your everyday computer. That's just asking for trouble.
And this is like rule number one. It is absolutely non-negotiable. Our source material for this is crystal clear. You never ever run malware on a machine that's connected to anything important. Analysts have to work in completely isolated labs to prevent any kind of accidental outbreak.
So they build this digital clean room. What that means is, first, they create a virtual machine. It's literally a computer inside their computer. Then they completely sever its connection to any network. And here's the really clever part. They take a snapshot, which is like a save point in a video game. If the malware wrecks the system, they can just hit a button and reset it back to pristine condition in seconds. And this whole setup has a name. It's called a sandbox. Honestly, the best way to think about it is like a bomb disposal chamber, but for software. It's the safe place where an analyst can detonate the malicious code and watch the explosion without anyone getting hurt.
All right, with the secure lab all set up, the real investigation can finally begin. But here's the thing that might surprise you. The first step isn't to just run the malware. No way. It's to read its blueprints without ever turning it on. See, analysts use two core methods. First up is static analysis. That's like a mechanic examining an engine's design, looking at all the parts before even thinking about turning the key. Later, they'll do what's called dynamic analysis, and that's when they'll finally power it on to see exactly what it does.
And you would be amazed what you can find just by combing through the raw code. An analyst can spot little clues, like suspicious web addresses, file names, or commands that tell the computer to create or write files. All these little breadcrumbs help them form an initial hypothesis about what this thing is designed to do.
But let's be real, you can only learn so much from blueprints. To truly understand the threat, you have to see it in action. So, once that initial check is done, it's time for the live test.
Based on all those clues they found, the analyst now has a theory. In this case, they're thinking, okay, I bet this program is going to try and phone home to a command and control server to get its instructions. Now they're going to run the code and see if they're right.
And here we go. This is the main event. The malware gets executed inside the sandbox, and a whole bunch of monitoring tools instantly light up to track its every move. Every file it creates, every network connection it attempts, every change it makes to the system, it's all being watched and logged.
This live test, this is the moment of truth. This is where the malware shows its hand, revealing the most critical evidence of all, its unique, identifiable digital fingerprints.
And this right here is the payoff. This is what it's all about. The analyst now has concrete, actionable intelligence. Things like the specific domain name it contacted, the exact file path it used. These are the smoking guns. In the industry, they're called indicators of compromise, or IOCs. Armed with these digital fingerprints, the analyst can now do something really powerful. They can write what's called a Yara rule. Think of it as creating a custom-built wanted poster that can be used to hunt for this exact threat across any other computer or network.
Yeah, a custom-built alarm system. That's the perfect way to think about it. This signature gets shared with security tools and antivirus programs all over the world. It essentially teaches the planet's entire digital immune system how to recognize and neutralize this specific threat.
So what's the big picture here? All that hard work on this one single suspicious file, well, it has a much, much bigger impact than you might think.
Seriously, the painstaking work of this one analyst feeds into a massive global defense system. This kind of intelligence helps protect everything from your personal data and bank account to the critical national infrastructure that we all depend on every single day.
Which kind of leaves us with this final thought. This digital detective work is just a snapshot of a relentless, invisible war that's being fought every second. And in this constant cat-and-mouse game, just understanding how the defenders fight, that's the first and maybe the most important step in staying secure.